Kimi is a very idealistic, a hub of really smart young talents gathered together to achieve a very idealistic goal. Them and also DeepSeek, really hard working driven people that were able to develop great open source models. I think they will be able to alternate the number one spot in the open weight model across the time.
This debate over distillation in general and ByteDance's decision to not do so.
I think it's a very brave decision. The head of ByteDance to say that this is not the road we're taking. If you go down that route, it will give us a false sense of satisfaction because we achieved this in the wrong way.
How has open source changed AI?
If you're talking to the frontier labs, the researcher and so forth, they haven't cared much about this.
Hello and welcome to Valley 101, an independent media covering frontier technology and the most interesting business stories. My name is Yiwen. Today, I am speaking with Meng Xing. Xing is a partner at 5Y Capital, a Beijing and Shanghai-based venture capital firm. But today, I am speaking with Shane in San Francisco during his quarterly trip to the Bay Area. Before 5Y, Shane has spent 5 years at Didi Autonomous Driving as an operator, and he has also founded 2 computer vision startups earlier in his career, Obius and Cogto, and he sold both of them. This is actually a very interesting time to be catching up with Shane. A month ago, Kimi K3 was released, and that shocked Silicon Valley and prompted a conversation about open weight models. So we touched upon a lot of those topics, but we also talked about Chinese frontier AI labs, neo labs in China, AI in sciences, and all of these different application and verticals. When it comes to China AI, there are a lot of curiosity, but also a lot of misconceptions. And I'm really glad to be here and unpack it with Shane. So here is our conversation. Xing, welcome to Valley 101.
Thank you for having me.
Great. So, you kind of split your time between Beijing and Silicon Valley. You come here once every quarter. What was your biggest takeaway from this trip in the Bay Area?
So before we came here, that was about a week ago, we had a few themes in mind, and we want to explore the extent of those themes. How did they play out in the Valley? We wonder, models like Kimi or DeepSeek, we saw a lot of buzz and discussion either on Twitter or on even in, Congress and stuff. But what are their real impact in terms of to the frontier labs or to the agent companies and to researchers in general? Are they really that concerned? Are they really paying that much attention to that? How does that change the economics of the world? Especially playing up to the IPOs of OpenAI and Anthropic. Does that have an impact? I don't know. We thought it would be, but we want to see some proof. Second is that in the past 3 years since the launch of GPT 3.5, I think the key theme has always been pushing out the next best model and to reach the ultimate performance beyond imagination as in being the top performance of all benchmarks possible. Then now we're reaching a point where we want, well, not us, but the model companies, they want to penetrate more users. And the users have to go beyond coders and other type of users. So they want to adoption rate goes up and to more diversity. So you're looking at people that want to care a lot about efficiency, care a lot about serving speed, rather than only the ultimate level of intelligence. So token efficiency is important, and the cost of that, the routing of the right model to serve this specific task is important. It's number 2. 3 is AI for science has been a big factor. One of the big focus for me and for my team for the past almost a year now. We're looking at breakthroughs across biology, across material science, across even traditional drilling, for minerals and stuff, and applying AI in those directions. Every time we come here, Silicon Valley is not only a hub for AI, but also a hub for general science. So those are things that I'm most looking forward to and spend a lot of time on.
Nice. So open source and then this transition from capability to kind of speed and inference and then AI for science. We'll dig into each of those. Let's start with the foundation models. And so one of the things I thought was really interesting in the US is that we're kind of getting into this two-tier ecosystem. We have Anthropic and OpenAI, and they're kind of the duopoly in the startup world. And then we have the public companies, the bigger companies. We had Google and then Meta. Things kind of look similar in China as well. We had the so-called four dragons of like AI startups that focus on foundation models. And then we have the bigger companies like ByteDance and Alibaba. And would you agree to that characterization? Is that like a good way of looking at the foundation model labs in China?
Sure. I think those are the main ones.
I wanted to talk a little bit about the specific companies and kind of love to know like how you think of them from an investor perspective. Let's just like start with Moonshot since we've been talking about Kimi K3 for a while. What kind of company is that?
I think Kimi is a very idealistic and they're a hub of really smart young talents gathered together to achieve a very idealistic goal, which is, AGI. At the very beginning, it was like three years ago. And today it sounds so normal. Everybody's saying that. But 3 years ago, this is actually quite, people would think this is, you're too ambitious for your credential in that way. But they held that ambition or held that aspiration throughout 3 years. They've been at the peak of media attention. They've been gone through horrible times, and they're now back at the peak again. But I don't think they changed much in terms of what they think of what they do. So they're pretty much very focused in terms of they're not an application company. They don't build a lot of multimedia models, and that way they're laser focused on building AGI in a sense. And that's one. Two is they're one of the companies I think probably has the best atmosphere for young researchers to join. They allot a lot of attention and resources to interns, really young interns. They have interns that are, almost in high school which is, not very usual, or able to have access to a lot of, compute power and resources so that they can build actually very important components of the latest model, K3, that was just launched. I think they're a team first or culture first company where they sort of establish a very much attractive goal and attractive talent, and we're laser focused on that goal throughout. And if you talk to people in that organization, I think they will tell you the same. They're a very small team today. I think they're still maybe less than 400 people, more or less. If we talk to the companies here in the U.S. and if I were to ask them to guess how, you've seen K3, you've seen the buzz, you've seen the performance, and how many people would you guess this company has? People will be really surprised to think they only have 300 or so people at this point after 3 years of development. It's not that they don't have the resources to hire more. They decided to keep the team small so that they can be intact enough to know everybody was working on, and they're close enough so there's no context lost when they're building things together.
Knowing that team, did the release of K3 surprise you? Do you think that kind of proved that they have been on the right track all along?
I think so. I think I've always expected them and also DeepSeek, and I think that those two teams are actually in a way I would say 80% similar, 20% not similar, but on a similar side, they're really hard-working, driven people that were able to develop great open source models. So I think they will be able to alternate the number one spot in the open source model, open weight model across the time. But to be so close to the closed source model, even if you're number one on the ranking of open source model, is still amazing. So I think they were able to hit, I think, if I remember correctly, when they launched Kimi K2 about maybe a year ago almost, that was a big hit. That was like one of the models they were able to get the world known about them, especially the US know about the Kimi at the time. But that was, I think, ranked number 6 or number 7 on the closed model list. If that were, it was an open source model, but if we're not open source, then it will be number 6 or 7. Now they're getting close to number 2, number 3 on that list, being an open source model. So that really, surprised me. as well. And given how limited resource they have in terms of compute, in terms of people, and also importantly, and this is widely discussed as well, is that they made a lot of fundamental innovations in the model architecture on this model that they just released. And although they have tested out a lot of those on the toy model in 40 billion parameters or 30 billion parameters, it's still a big feat to integrate those research efforts into the actual 2.8 trillion parameter model, which is a huge feat. Normally, you want to stay on the safe side, and when you introduce something as dramatic as those type of architectures, it usually bring down the model performance rather than go up. And then over time, it probably the net effect will be going up, but the short-term effect will be actually dragging down the model. But they were able to integrate that together, but bring model size into almost 3 trillion, and with limited compute and very short timetable, we're going to push that out. I would be lying if I was saying I'm not surprised.
Was those constraints in terms of compute and then being able to fit those architectural innovation into the model, is that something being shared among the Chinese frontier labs, would you say?
The compute?
Yeah, just I guess that.
The technique for computer?
Yeah.
I mean, the infrastructure optimization type of technique. I think it's been shared across the world, more or less. It's sort of a little bit surprising to me. So when I visited a lot of the labs here, frontier labs here in OpenAI, Anthropic, and Gemini, and they, a lot of especially the infrastructure guys, they look up to the young guys at DeepSeek and sometimes in Kimi as well. A lot of the world-class innovation comes from those labs and comes from the really young guys that are born in the 1998 or later, the hands of those people. They're not just innovating on a best of the country, but they're innovating in the best of the world. And that's under willingly or less willingly because they don't have the resources and they don't have the support. They have to do it this way. And if you provide the resources scarce enough, then magic will automatically happen in that way or less if you put enough great people in that sense. So yeah, I think that's what we're seeing what that happen. But then once it's released, if you look at the latest architecture between Kimi and DeepSeek,
there's some similarities.
There's a lot of similarities,
yeah.
but also different because DSA, DeepSeek sparse attention is very different from KDA, which is Kimi's sort of architecture. But there's, in terms of principle, in terms of philosophy, there's a lot of things that are similar. And then you see this iteration, like when I release one model, they launch this feature, and then the competitor's model launch this feature, and they go up side by side. So yeah, I think definitely there's a lot of sharing in that way. But then I don't see the type of sharing that happens a lot in the U.S. team where there's so many liquidity or mobility across the different firms for individual researchers, right? You see somebody at OpenAI one day, and 2 weeks later they're another firm. This happens almost every day, even on the very senior level. But I think in most of the labs in China, this is less frequent. They're either in China and there's labs. They work their way up, or they maybe start startups, or maybe they come to U.S. labs. But moving across Chinese labs in a very known fashion, that's not as common as it is in the U.S.
And because of that, would you say that each Chinese lab kind of has its own character in some way?
Yeah, I would say it's shaped by the people that they're, but also shaped by mostly by the founder, I believe, as well. And you attract similar people to you once you set up the company as a founder. So Liang Wenfeng is a very unique founder, but unique, and Yang Zhilin is a very unique founder, but they're unique in very different ways. And Tang Jie, obviously, professor at Tsinghua, they had their prodigies across his alley. So all very different. And as a result, yes, I agree with you. Different character company.
Let's talk about DeepSeek. What's unique about Liang Wenfeng, as you just mentioned, and then what makes DeepSeek as a lab unique?
Yeah, the guy is so unusual. So I didn't know about this guy until DeepSeek, although I should, because his hedge fund is so important in the China finance world. he, in general, the perception is, so I never, by the way, the caveat is, disclaimer is I never met him in person. Talked to people that at his firm. But he seems to figure out the world at a very early stage in terms of how to be rich, how to make money, how to trade, how to hire talents. But, in the contrary, I don't think he has much interest for wealth, for influence, the typical things that, people at this age would want to maximize. And so it's sort of, even, jealous to a lot of people because, he has the capability to build that, but he doesn't capitalize on that. He has a very pure and idealistic view, almost, the same words I used to describe Moonshot in a way. But yeah, I think that they share that in a way. They believe in hiring raw crew talent from China. They are not a big fan of recruiting high-level, well-known researchers from the top labs in the U.S. or established researchers there. They believe in young, fresh talent coming out of schools and building great work out there. And people work really, really hard. I think there was like a few weeks ago we had this. I think there was like friends of ours in the venture capital industry try to take photos of companies' floors at 9 p.m. and then at 10 p.m. and just see how percentage of them are working after 9 and so forth. And those two are the hardest working firms across many different firms out there in terms of percentage of people still working by then. Probably partially due to they come to work late in the morning, but yeah, I think that's sort of a partial. But a lot of this is really voluntarily. They really love to work there. Yeah, so the innovation they've done in terms of infrastructure, parallel computing, the MHC, all those types of the DeepSeek, sparse attention, all are very innovative work. A lot of our friends here at the labs at Google, when they saw the release, because they do very detailed release of those technology that they do, and they open source not only the model but also a lot of they're still one of the labs that write thorough enough tech papers so that people can actually read and replicate what they do rather than go through a whole process of figuring it out on their own. A lot of the researchers here in the labs here, they figure, when they read those papers, they will say, wow, I never knew this can be done this way. There are really some crazy people that try to spend a lot of time really grinding out the details in that way and so forth. So, which is sort of surprising because, you would think that, those, whatever DeepSeek and Moonshot have figured out, should be already figured out by the labs here, who are training models that are 10 times larger and, dealing with problems that are 10 times harder than the Chinese lab. But that's not the case.
What about Z.ai and MiniMax? Both of them also launched models recently.
I think Z.ai is, they enjoyed a lot of great reputation since the launch of GLM 5.2, which is a model that is doing really well in coding. And adoption of that model has been wild across China and U.S. They're also very, very lucky to be listed early on. One of MiniMax and Z.ai are the two companies that went public in Hong Kong 8 months ago or so. And the market value of Z.ai obviously when it skyrocketed to, was it 1.23 trillion RMB, so almost 200 billion, right? Or a lot larger than a lot of the Chinese legacy internet companies out there, which is people think are crazy because they have very, very small revenue at that year in 2025. But I think they're doing some really nice work. They have a larger team. They were built around, Professor Tang Jie and his students who had worked with them for many years, and they had expanded into a lot of different directions and product suites, and they have computer use, they have multimedia, and different type of things. But I think relatively they're less focused. But nonetheless, they're able to push out some good work. But I think the culture taste or the feel is a little bit different from the two Moonshot and DeepSeek, the companies that we mentioned. This is more a full-fledged AI companies that are sort of like OpenAI in that way. MiniMax, on the other hand, is also listed. Their stock price has enjoyed a roller coaster ride. It went up alongside with Z.ai and then dropped significantly to, I think today they're probably around their IPO price, a little bit higher, but probably 5 or 6 times lower than their peak. I think relatively, they have been strong in serving. When they started, they were known for pushing out really not just training models very early on, but also be able to push out really good products, similar products to character AI and so forth. And they're almost defined how the Chinese company should build companion AI products at the beginning. So they built some very famous product. And then they pivot towards building multimedia models, which M3, the High Lilith series, are very popular for once they launched. And I think recently, again, it's quite a great model. But I think they haven't been very successful on the pure LM side in terms of reasoning, coding, and so forth. Their highlights usually are around are the peripheral of intelligence, rather what we call it, right? Rather than the coding or LM, it's the multimedia, it's the products, it's that stuff. And I wouldn't say this is a bad thing. I think it's their unique trait in that way. They're able. I think once there was a time, 2024, I think early that time, there was a time that I realized that all the people, the young, really talented people that were otherwise to join ByteDance or TikTok, the cool people, all joined MiniMax at a time. And they were able to recruit a lot of, not the researchers, but the product managers, the developers, those sort of go-to-market people. They were able to build a really attractive firm. Like the vibe is sort of like TikTok in a way. And they actually got a lot of TikTok people to join as well. So they're unique. I think they're quite different from the other labs, as I mentioned it.
There has been a lot of discussions about distillations from the Chinese labs recently, with the exception of ByteDance recently. In an all-hands meeting, it was reported that Zhang Yiming told the staff that they are going to refrain from distilling frontier models in order to preserve kind of the technological capacity, the ability to develop their own technology in a way. And really curious about your take on that, on this debate over distillation in general and ByteDance's decision to not do so.
I think it's a very brave decision to that. And alongside with, I think I read the original comment is that even if, this is coming from Zhang Yiming, is that even if it means that we're going to be behind our Chinese peers in terms of large language models, we will still prohibit distillation from the other labs or so forth. I think the key part is not prohibiting distillation, is that the condition for that is even if we can start preventing, because people don't think Seed or ByteDance large language model is a product that is behind other people. So, it actually made me be alerted in that way, is that if you don't distill, that means you're going to be behind, or you're already behind. That's actually a bigger news for me. I think it's quite brave, because when you think about distillation, there's two types of distillation. There's one type that is blatant distillation, meaning that you have a set of prompts that you think covers the distribution of what user usually want. And then you send those to the frontier models, and you extract sort of, in the case of cloud, you actually extract the chain of thought in between. In the case of GPT, you don't have that, but you get sort of certain return back, and you train on top of that. But there's also the other type of distillation, which is, if you think about it, a lot of the data we use today are synthetic. It's not purely made by human by hand, right? And you wouldn't call synthetic data distillation if you use to train on that. But then if you think about it, how did you create synthetic data in the first place? It's human using a model to create synthetic data. So when you, by default, the synthetic data distill the model which you used to create it to begin with. So then it's indirect distillation in that way. And from that perspective, I think everybody distilled something to a certain degree. So it's probably not blatant COT, but they distill some certain intelligence there. So far, it's been proving both. Synthetic data is obviously a substrate of all training today. It's very important. It's probably the key to scaling up training. But blatant distillation is very effective, as we probably see. I have no evidence or proof of. I don't want to say who's doing what in that way, but from what I see, it's a very effective way to do so. Having the head of ByteDance to say that this is not the route we're taking. If you go down that route, it will mean that it will give us a false sense of satisfaction, right? Because we achieved this in the wrong way, and then we thought we'd be good, but we're not. Is a very brave and sort of very suggestive of what who Zhang Yiming is and what he wants to build Seed to become, which is we can afford to be behind for a few years, but we ultimately want to be the top of the world. And in order to preserve that ambition, you have to do things the right way and the unique way.
Can anyone afford to be behind for a few years in today's AI competition landscape?
If you don't have to raise funding, yes. Mm. So in the case of Zhang Yiming and in the case of DeepSeek, I think they have the luxury to do that.
Interesting. So the reason why distillation obviously has become such a hot and controversial topic in the US is because of the open source models in China, and they have become so capable. K3 kind of proved that, but even before that, there was the DeepSeek moment last year, and then GLM 5.2 was released. And I think the US labs are kind of alarmed at how good the Chinese models have become. And this is when we went back to kind of your purpose of coming to the Bay Area this time around. You wanted to see the impact of open source, I guess, the industry on applications, on the entire agentic AI ecosystem. What have you seen so far? How has open source changed AI?
I think the interesting observation I had is that despite the heated debate and also the great attention that has been placed on, open source and K3 and so forth, if you're talking to frontier labs, the researcher and so forth, they haven't cared much about this. Few of them actually have tried those models. And that was a surprise to me. I thought this will be, this is sort of your direct competition, right? And this is, not just only from a competition standpoint, but also from a sharing sort of, tech report and papers perspective. You should be learning. This is less of their attention. From an agent developer standpoint, a lot of them, especially seen on the news, has switched to K3, and as a result, what I heard was that is a significant impact on the revenue top line of the frontier labs, especially Anthropic, in the way. So we're at the point where total token consumption in July has been growing slower than expected. Some would say it's stagnated. And if you look closer into that, that's only consumption. But if you look at token revenue, because a lot of people are swapping from the frontier models to the cheaper models, so the total revenue, if it's flat in terms of total token consumption, let's just say, I don't know if it is, but let's assume it is, then total revenue will be going down because people are swapping more expensive model with cheaper models in that way. So there's large impact. And the reason behind that is, you're seeing the agent companies, the users, the individual coders, they are making that change as well. And there's innovative ways to do that. You might not swap it all the way. You might be using, say, the likes of K3 or DeepSeek to write your code and then still use Claude to review your code, right? Use a combination of that to maintain certain accuracy and performance along the way. And well, for most people, you can hardly tell difference from that perspective, unless you're very, very intense users or you're using it for highly complicated problems in that way. But then if you look back, even among the Anthropic models, between Fable 5, between Opus 5 and Opus 4.8, sometimes even Opus 4.6, people can't decide which one is better for their particular task. Sometimes 4.6 is better, sometimes Fable is better, which is supposed to be because it's a larger model and use more training cost to do, and it came out later. So yeah, you're seeing, but all of them are more expensive than the cheaper models. K3 is actually not that cheap. Compared to DeepSeek, which is usually the cheapest way, but it's still cheaper, obviously, than the Anthropic models of the same size and so forth. So this is happening and hitting the token economy a lot, I would say, and so the agent companies really care about this a lot, but the top frontier models less so. And as a result, this discussion hasn't been that helpful so far. You're only seeing migration of adoption rate going up. That's sort of expected and what we learned, but there's less discussion of what can we learn from those models, what should we take, and what is the good and bad about sort of from the researchers here. Their commenting of the model is less because they haven't spent much time on it. Yeah.
So are we at a stage where it has become kind of hard to differentiate between the different models for a normal company or like regular users? And if so, what are the implications on the frontier labs in both US and China?
I think if your main task is not to build the next frontier model or to build next great database or build complicated things, complicated coding, things like that, or to solve the hardest math problem on earth, then for the most part, I don't think you'll be able to tell the difference among the top models that easily. The penetration of coders for using models has been really, really high. It'll be very hard to find a coder that doesn't use a coding agent today. But the hope to bring up non-coders up high in terms of using the likes of Cowork or Codex to solve their, PowerPoint problems or report problems, the penetration is not that high, or not as high as the growth is not as high as expected. And it's partially due to the fact that there's two types of adoption. There's adoption from the company, which is pushing from top down, right? You have a business deal with your company, and a company adopted this, pushes every employee to use it. These are very slower than expected. Usually take their AI strategy usually lasts 2 to 3 years, and it took them 2 to 3 years to fully get compliance right, get the security right, and privacy right. That's just too long. So you're not seeing that adoption going really fast. On the individual level, first of all, you're seeing, on an individual level, on a lot of those tasks, you can't tell the difference in terms of capability among those models. Second is that a lot of the tasks, as you know, probably Fable and a lot of those top models, the advantage of those is that they can run for a very long time. So if you set the right goals, you set the right evaluations, and you let it run, it will be able to figure out a complex problem while you sleep, right? The next morning you get up, it'll be done. But for a lot of the white-collar works, if you're writing a PowerPoint or writing a report or so, it's very hard to predefine the goal as to, if you make this color right in this way, then this is a great PowerPoint. It's very hard to, set this before you see the PowerPoint. So human is always in the loop in that way, meaning that you have to be in front of your computer. And even if the work is done by Codex or cloud, you still have to be in front of a computer to check the result every time. And then when you see the result, you look at it, you think about it, you brainstorm, and probably set up some new goals, and you give it. So that means the token throughput cannot be very high because it cannot run continuously for a very long time, because you always have to be in the loop to do some work to check. And hence the reason why I mentioned, I think token throughput should be a very important issue among this, because if you build a PowerPoint, let's say, in 10 seconds rather than 10 minutes, then you can have more iterations of that loop for the non-coding work. And so to bring up the total token consumption in that area. But this is not yet happening. So you're seeing a rather stagnation in those areas so far, beyond coding. The third part where token consumption can go up would be multimodal, multimedia models. That is, you're seeing CDANs obviously going up, and we talk a lot about LLM, but ByteDance has built this really powerful tool, CDANs, which is a best sort of multimedia model coming out and making a lot of revenue, probably best in the world by far. That is, my personal belief is that's probably the most promising tool for the next level of token consumption. But it has to be improved better and have to be more interactive. The serving speed has to be faster for this to work.
Yeah, let's talk about multimodal models and video in particular, because you mentioned C-Dance. I actually thought this is a great segue into kind of the applications layer of AI in the US and China, because video models is one of the things that we're seeing. There's this kind of like a sharp contrast between the US and China. Like in China, we had C-Dance, we had all of those startups working on video generations. And in the US, so that attempts have kind of faded, I think, over the past year. OpenAI kind of like stopped the Sora 2 release. And I thought it was interesting comparison. Why is China, I guess, the Chinese labs good at making video models?
I think first of all, there's the resource allocation part, and there's also the privilege part, right? The resource allocation is due to coding has been so important that everything else should be less important, following that narrative, and this narrative has been more and more central to the scene since, I guess, January of this year, right? In the early part. So everything that consumes, compute is cut to preserve enough compute to make sure that coding is, as good as possible. But, and this, I think, this is not to say that this is not happening in China as well. I think it's also happening. But then if you travel back in time and say you're in 2023 and you would have to guess, 3 years later, who would have the best model, multimedia model in the world? I think the easy guess would be, ByteDance, Kuaishou, and Meta, because they have the most training data, they have the most multimedia platform, they have the best distribution platform, and they have enough cards and so forth. So they know They have data and they know the product, what the product should train towards, and they have the distribution channel for that. But it seems that Keling, which is the model for Kuaishou, worked out, was number one, and then surpassed by C-Dance, by ByteDance. But those two were expected in that way. C-Dance was really great because they took a very aggressive but risky shot, which is to train a much larger scale model than all the multimedia model before that. I think they upscaled by one magnitude. And they did it on, I think, when there's very little evidence that will work. So looking at it from a retrospectively, it seems the obvious choice, and everybody's doing it now. But back then, I think half a year ago or almost a year ago, it's not that obvious. So they took the reward for taking that risk.
Why was it a difficult bet back then?
Yeah, because most of the models are small relatively, and you use number of the training compute, the cars or the GPUs you're using in the thousands rather than the tens of thousands for that type of model. So being able to pull that resource out from training LLM models and coding, especially this year, this is a more and more difficult decision to do, especially when you're resource constrained. That was not simple, and I think that decision was led by a very, very young female researchers at C-Dance to do that, and she made her credit by building this. So kudos to her. I think that's a very great move. Yeah, but then what is disappointing is I think Meta, in a way which I suppose they should make a really great model. They have the data, they have the capability, they have the resources to do that, and it is in their up their alley. I think it's something that they should do really well, but so far I haven't seen the progress yet.
Yeah, I guess they did make Dream, and then Muse came out a couple, about a month ago.
Yeah.
Would you also say, is there like a consumer demand for this in China? Because, in the beginning, we talked about this consumer-facing applications. MiniMax was doing that. Obviously, it was a lot more like companion works. But like in China, it seems like there are a lot of consumer-facing AI applications. And C-Dance obviously is being used by really everyday consumer. Everyone is making like TikTok videos about that. There are like AI drama, short drama, very popular on social media. Is that also what constitutes, a different market in China versus in the US?
I think CDance is mainly adoption goes up, and especially revenue goes up. My view is it's not yet mainly contributed by individual consumer users. It's mainly by prosumer users. The reason you can say that is because you look at the applications that are built for prosumers, their revenue went up significantly after the release of CDance.
What are some examples?
TapNow, LibTV, for example, those are the ones. So TapNow is those two products are similar, but essentially they are a canvas for building videos. And for advertiser builders or short video builders, they use the canvas to sort of set up a workflow to generate certain videos. And, at the beginning of the year, those companies were looking at, revenue in the small millions or mid-single digit. And then after CDance release, they're quickly hit up to almost 100 million or plus or so forth. And that's a super fast growth. If you look at the deals they're making with, it's even hard to get CDance tokens at some point, right? You have to prepay for a certain amount in order to allocate that. Yeah, so those are the buyers of CDance API, and the user behind that are the prosumers who are making videos for AI short films and advertisement and all that stuff. So as an individual, I don't think the spending has gone up that high yet. But there's the short film market, the short video market has been going crazy, and short film has been, I think, is surpassing like the movie theaters. I think I already surpassed movie theaters this year.
Oh, this includes both human acting and AI short films, right?
Yes.
Yes. That makes sense.
Yeah. But then, because short films, I think in the past. We're looking at this as an investor. We look at a few companies doing that. My view was that AI-generated short films are great at, the sci-fi type of themes or the traditional China sci-fis or ancient, swordmen, and because it's really great at creating special effects. It's not very good at creating very detailed human emotional reactions so far. If you're filming like a high school drama for with a lot of dating and small intricate micro expressions, it's not very good for that in the past. So they're good at certain genre in the Chinese film, which is good. It's good enough because those genres are most popular to begin with. But now after CDance, it's already very good at all the CDance. A lot of the CDance demos there's two types of CDance demos are most popular. One is making very, very intricate emotional expressions, and that you have to laugh and then cry, but a very smooth transition across that, and then. It's better than human sometimes, better than actor. And two is that CDance, I think, specifically spend a lot of training effort in terms of making sure that highly dynamic motions are fairly captured. For example, if you're engaged in a kung fu fight between two actors, in the past, sometimes if you hit someone, usually the hand goes through their arm and to the other side, or it just look unnatural in some way. But it's very hard because it's happening very fast. The frame per second the action cuts into few frames, but the action sometimes it blurs out, sometimes it's wrong. So I think the CDance 2.0 version has spent a lot of effort in improving that, which is one of the most important feature for AI short films. So as a result, it's become almost the exclusive provider for a lot of the short films in that way. Yeah.
I actually thought it was interesting because in one of your previous interviews, you mentioned that one of the applications that you look forward to is kind of this middle ground between video and games, this interactive form of media. Would you say that AI-generated videos are kind of a step towards that? Like, are you seeing, because one of the examples that you gave in that podcast was Fable Studios' remake of South Park with AI. And are you seeing more examples like that with the advancing capabilities of AI videos?
I have to say that I'm a little disappointed since when I made that interview afterwards. I still had high hopes of that become a mainstream type of media, but I don't think it played out as I expected so far. I think naturally there should be a place where ease in between watching TV, which is leaning back and doing nothing but minimum interaction but mostly consumption, versus playing games, which is leaning in and doing intense interaction. And there should be in between, should have like a medium interaction but endless content type of way, which is generated content in that way. So it's sort of between games and media in that way. I don't think we're there yet. I think a lot of there's this thing called 影游, which is sort of that, which is sort of half movie, half game. You get to play. There's a theme. There's narrative. I think it's sort of a recreative. The game, the famous game called Become Human Detroit, which is a video game. Probably 10 years ago or so. There's a lot of those content coming out, but I don't think it's of high quality enough yet, so that becomes a very popular genre. There are single hits that are making a lot of money, but it's not taking off yet as popular as AI short films in that way. Yeah.
Yeah, but you still have hopes for that.
Yes, yeah. I would love to see that happen at someday. I think this will be bigger than games itself. Yeah.
Nice. I guess world models would be kind of a form of that,
sure.
Which we'll get into because we're going to talk about NeoLabs, and that is one of the verticals I really wanted to get into more, because in the US it has become pretty popular to invest in NeoLabs that are funded by those young researchers, or a lot of times experienced researchers that spend a lot of their time in a academic environment. And in China, you mentioned that you have been looking at a lot of the AI for science companies and startups as well. Tell us a little bit more about that. Like what are NeoLabs funding looking like in China compared to what you've done in the US?
So US has been, NeoLabs has been the favorite of a lot of venture capital over the past year or so. There's obviously much more funding for this to happen in the US than in China. I think China is more practical. There are new NeoLabs coming out. For example, the head of Tianwen's model, Lin Jinyang, founded his lab. Famous researcher Dai Jifeng founded his lab. Overall, I think my view is that the concept of NeoLab has changed or is changing along the way. I think in the past, NeoLab is exclusively what I mentioned, what I defined just a moment ago. But I think now, when we think of NeoLab, or I think what should look like a NeoLab, I'm thinking more like Cursor, meaning that they're an application company to begin with. They build a super app, they gather user data, they have user trace, and they decided to train a model. And they were able to do that precisely because they had a super app and they had the user trace, and they are able to build a great model, which is Composer, by just doing post-train rather than doing pre-train. And that model was able to beat a lot of the pre-trained models out there in the world. That, I think, is the right recipe for a NeoLab these days. It's not a new methodology. You have a new set of data, and that the Frontier Labs doesn't have. And you'll be able to capitalize on that data and to build something different. So when I think about NeoLabs, I'm thinking about the most popular apps today out there in the world. And at some point, they will decide to train their own model, either post-train or maybe someday even pre-train model, maybe. And they will have to do that because they will want to, number one, lower their costs, and number two, possibly to build something that is customized for their particular application. And you're seeing this happening at Harvey, at some of the vertical applications agents here in the US. And I think you will be seeing this happening in China as well.
What kind of companies would you say were the most suitable for doing that? You said it was the company that has the user data and has an app.
Number one, you have to have enough user data that is untouchable, that is unique to you. Two is the data is better suited if they are in a vertical rather than general, because then you're not only training a model to get a cheaper model to replace the lower cost, but also you actually have a shot at training a model that is unique. But if your application is general, then it's hard to train a unique model because essentially, take the general agents, for example, or some of the search engines. Users use that in a very general purpose. So essentially, their prompt is similar to what Claude and OpenAI is trained for. But if you're looking at just a legal vertical, you're looking at a medical vertical, then you're solving a particular problem. You potentially can tune a model that are specifically for that purpose, and it's easier to build a model that beats the general models in that way, and on top of your unique data. Yeah, so I think vertical plus you have a super app in that way. I think the question behind this is that, and I probably want to touch on this a little bit, is that what should model be trained? What should any model be trained towards? What is the goal? What's the evaluation for that? Today, when you look at frontier models, the key, everybody knows the key to improve that is data, right? But who decide what data to use and to purchase? It is the researchers that are owning the training of the models. So a lot of this is the data they would use is attributed to the key researchers' own taste. But then there's some bias towards that because if you're a researcher, obviously you're very familiar with coding, you're familiar with probably math as well, but you're probably not going to be very familiar with office work or that because you personally never done it, especially if you're a PhD just out of your PhD program and directly into a frontier lab and being put into a key role. You've probably never done much of PowerPoint work or report work before, or accounting work in that sense. But then they're acquiring human labeled data and now environments to train the models on that. But the true environment, what the model should be measured against in the future, it should be the exact environment that people are using, right? The Slacks, the Zoom, the SaaS softwares, the Salesforce software that people are using, and there's some goal in there, and then people make some effort doing trajectory to solve certain processes over that. And Cursor is one of those examples. That is one of the, say, SaaS software that people use. It's one of the most popular software. It just so happened that is a coding software, so this happened really early in the days because it's something that the researchers are very familiar. But in the future, I think those will be the true environments. Those are the working environments that are truly measure of how good the model can work at. It's not some imaginary environment that imagined by the researcher or according to their research taste in that way.
That's interesting because I feel like before a lot of discussions happen around how when you were developing foundation models, we have used the world's data already. We have really drained the internet. And that's why people are looking into synthetic data. But it seems like the future of data lies in those specific verticals. And would you say that these are still unmined territories? There are still a lot of data when it comes to specific use cases and verticals?
Absolutely. I think there's a long way to go. So in the past, data are static. You crawl from the internet or you synthesize certain data, but those are static data. Today, the most popular data are environments, right? You don't build a piece of data. You build an environment, like a SaaS software, for example. That's an environment, and you can let your model to attempt to do a bunch of tasks within that environment, and it will try on it its own, and it will do reinforcement learning along the way. Once it be successful, it'll be rewarded. If it's unsuccessful, it'll be not rewarded in that way, and it will learn on its own. But then if we're talking about environment, then there's a lot of environment to be built. We start with the most static environments, right? So what is a static environment? For example, if you want to something called kernel optimization, which is very popular in terms of reinforcement learning today, you try to write certain CUDA operator so that it runs your model faster, But the environment is set. You can rerun this a million times and it won't change. And you'll be able to roll out the test equally and stably. So that's the easiest. Next is called partial observation, is that what if you can't tell what the environment, all the parameters are? For example, if you're in your Slack, if you're a new employee and you join a new company and you're in the employees group chat and you're trying to figure out like, what does the boss want, right? You don't know what the boss wants. You have to observe, and then gradually over time you probably know because you're only given partial. Somebody probably tell you, the boss wants these, but it's not specified. Their information untold. Over time, you learn this, maybe by exploring, by interacting with other people and so forth. So this is called partial observation optimization in that way. And that's sort of true to most environments. You don't obviously know the intricacy of everything to begin with. And then there's the static versus dynamic, is that every action you, for example, in a finance or trading environment, every action you take changes the environment itself. It will never be able to roll back to the original environment again. So every test you do, you change it. And then if it's successful, it might not be successful in the next step because the environment changed over time. So how does you adapt to that? And that's sort of new environments that you have to build. This is new data, and you have to create this, like social media is that type of thing. Every post you post changes everybody around you, changes your fans' perception of you. So you cannot do the same experiment 1,000 times and just see how it works because, the accumulation of the previous 999 times is in the mindset of already are in your fans in that way, and it changes their behavior. And from the virtual world to physical world is also a direction where you can build. For example, I think there's one benchmark I love. There's one environment or sort of data that I love to share. It's called the vending bench. I don't know if you heard of it. It's essentially a company called Anton Labs. We just went to their office right before this. They created a benchmark, which is virtually setting up 3 different vending machines and asking LM to run those vending machines. And the LM can decide who to order the products from, set what price, what's the marketing strategy, and so forth, and just to see how they run it. So. And that's an attempt from going from virtual world to the real world. And although those 3, the benchmark was set up for virtual machines, they sort of created this in the mind of the LMs not to really set up. But then they set up a market, I think, at the Anton market, close to here, is really a shop, and to let LM to run the shop in that way. And just to test out, if your LM is so good at reasoning, at doing all those work, can you run a shop in a physical world that has so much unpredicted things that could happen to this and still run it well as good as you think it would be? And you change different models to do the same thing. So those are, obviously those data are not on the internet, cannot be crawled before and have to be made on the spot and while you do that. So there's a lot of things that can be done.
So speaking of data, there are also a lot of data providers, data labeling companies, and Silicon Valley Scale AI being one of them, but there's still a lot of demand for data. I know that you have visited some of those companies as well. Tell me a little bit about the state of those companies in the US and how different are they from the Chinese data providers?
I think we're seeing like a boom of revenue over the past 6 months. I know they're making a lot of revenue already in the past year, but this few months has been a significant increase for a lot of them. Many of them hit, 2-3 billion in terms of ARR in that scale. And some of the Chinese companies have been catching up, not to this scale yet, but very fast as well in terms of slope. But interestingly enough, if you dive deep into those companies, they're different type of companies. Although they all claim they're AI, LLM data providers, for example, some of them, like Scale and McCore, they sell their data in terms of headcount. So they sort of are pricing at the old model, which is like how many people they recruited to do how many hours, like the consulting or lawyer type of model. Whereas some of the new labs, they're pricing based on in terms of environments, right? One environment is sold at price from a few $100s to maybe $100,000, depending on how difficult it is. If it's small, like I would say, Booking.com environment, try to book a ticket, then there's probably $1,000 or less. If you're trying to build a environment where you want to test the agent capability to, say, like a DevOps capability to turn on a cluster and get a cluster somewhere else and to merge those two clusters and do some crazy work in terms of DevOps, then you sort of have to recreate almost the entire AWS experience for that. That would probably cost close $500,000 to that extent. So they're pricing on that, and those are sort of new lab models and that. And for the headcounts models, somewhat they're a lot of relationship driven. Because today, and we've talked about this a little bit, that a lot of the data are decided by the researchers and their taste. So it somewhat is a traditional to-B sales problem, whereas you have to make great friends with the researchers who can make the decisions. There's a lot of wine and dine in that process, and to make sure to happen. But that's one. So a lot of the traditional data providers are building business off of the typical business development and sales model, and there's a lot of new labs are building this off of. These are sort of the founders of the data providers are researchers themselves. They could have gotten really high-paying jobs at a frontier lab, but they decided to become a data provider, a founded data provider. And their unique trait is to anticipate the need of the researchers in the labs, 3 months ahead of what type of benchmark you want to be high on top of. So we'll create that benchmark for you. And then what type of data you will need, and we'll create that data for you. So we'll sell you a combination of benchmark to make that popular, and everybody wants to be high on that benchmark. And then we'll sell you the according data that will help you to get really high on that benchmark. So that's a different way of competing. So which is can you be a academic opinion leader, KOL, and to push up your benchmark, and then if you so, then you'll rightfully be able to sell all the data that will help in terms of that benchmark. So those are two, but this the prior one and the ones that are on human labeler or priced on that, and I think that the revenue is higher in terms of that, but the growth of the revenue is higher in terms of the latter one, in terms of anticipating what they need and building data especially for that. So that's really interesting. The China data providers, they are similar in a way that they started building sort of human labelers and building. In the past, I think one of the key benchmark built by Scale AI is called HLE, Human Last Exam, and that's mostly high-end expert labeling effort. And people started with that. I think almost every data company started with that. Now they're transforming into a lot of the environment builders and benchmark builders. So I think that's a trend. But despite which side you are, I think we're seeing revenue going crazy. And even at ICML, the academic conference like last month in Korea, South Korea, we're seeing a lot of young researchers, and we asked them, "What's your number one aspiration if you do want to get a job in academia, or do you want to build a startup?" So definitely want to build a startup, but we want to sell data. I want to be data providers.
Oh, wow.
That's a lot of those they're not building model companies. They're not building agent companies. They're building they're building data companies. So yeah.
Let's move on to AI for science, which seems like another thing that you've been looking at during this trip. What kind of companies have you been chatting with when it comes to building AI for science?
Mostly, so we're talking a lot of both frontier labs. They usually have a division looking at to science, and we're looking at a lot of those. This is one sector. Second is a lot of fresh PhDs that are scientists themselves, or in the cross intersection between computer scientists and say biostatistician or gene. People who do, I don't know the name for that. People who work on genes, or sort of people who are researching on physics and material science and so forth. So I think mainly coming from these two, and third is sort of professors that are specific in certain field, and they're looking to get some help in terms of, or moving across into the AI for science, because the barrier to enter AI for science is lower nowadays with the certain agents and so forth. So they are building their own capabilities across that. So frontier labs, researchers specialize on this area, PhDs, in the next intersection between CS and that, and then some professors that are in science fields.
What's the biggest challenge building AI for science?
I think it depends on what you're building. There's a lot of things that are thrown into this bucket called AI for science nowadays. There's a lot of them building AI scientist agents, which are essentially agents that can read literatures, design experiments, sometimes maybe control lab equipments, and to analyze results and to sort of do that scientific discovery loop, and maybe at the end write papers and even to publish papers. So that's sort of one. I think that it's not that hard to build these days. Every lab is building something of their own AI research scientists nowadays. It's just hard to build something that is really good, that is meaningful. And that way, essentially measured by you being able to publish a paper that is well received, right? And it's not that easy to do that yet, because there's a few steps, right? You have to analyze the literatures, and you have to plug into enough databases, and you have to plug into certain number of tools. But the problem is that the backbone base model you're using are still OpenAI and Anthropic's model, but usually they're not trained specifically on those type of scientific databases and scientific tools, right? So they're not really good at using those things, and sometimes you have to build certain workflows or certain guardrails to make sure that they do the right thing, and rather than just let the model freestyle and just run its own course in that way. So that's one of the difficulties. Second is that a lot of these experiments are done in wet labs, meaning that they have to have lab equipment, they have to have lab scientists to do the experiment in terms of to get the data back and to verify. So a certain process, it's not like math or coding, which is all the verifiers are online and accurate and online and stable. So it usually takes a long time, or sometimes it's just disconnected. Certain agents have to be, can go as far as experiment design, but executing the experiment needs human to intervene in that way. So those are one thing. So, but this is a difficulty in that side. But there's certain companies like Biomni and now Cloud Science and are all doing very well in building useful tools for researchers. There's also the other side, whereas you're building a model specifically for that. We're looking at so since AlphaFold, so DeepMind has been building great models out there. Since AlphaFold 3, there's been a lot of companies coming out and building frontier, state-of-the-art models like Chai, like Bowles, like DeepMind's own isomorphic labs. We invested in companies along the way building, protein design models as well as structured prediction models that are trained on public and private data sets to be able to design. And nowadays, de novo design, meaning design from nothing, right? You're just creating something that doesn't exist in the nature, antibodies or proteins, and to be able to bind to certain known targets so that it can solve certain disease. And we're also looking at to build world models for cells, right? Virtual cells. You can design. This is essentially the flip side of the protein design models, whereas you can design a protein binder, but then how would you test whether it can bind it well or not? You have to design a cell in order to see the interaction in that way. Otherwise, you have to do this experiment in a real lab, which is very costly and timely. So that's also very complicated because unlike robotics or the real world, you have cameras, you have all those sensors. For a cell, you have very, very minimal data to build anything to sustain a large model to train on that. So the data shortage is probably the biggest problem here. And then multimodality is also a problem, like enzymes and antibodies and antigens and peptides are very different things. How would you encode them all into the same model and able to represent them together? Otherwise, you have to build small models for each, and then that defeats the purpose of building one unified large language model or large model of any sense to be able to do the prediction. So those are some of the problems that we're seeing today. And also, essentially, all the things we're doing in bio. I gave you a lot of examples in biology, but essentially, the true verifier, we can have like intermediate verifiers today, right? If it binds well, if it is doing wet lab. But the true verifier is if this drug works on a human body, if it cures the disease, right? And that you won't even able to do that experiment unless you are like 5-6 years into the process until you hit your clinical trial approved by FDA to do that. So yeah, meaning you don't get any real feedback, full feedback from clinical trial until you're a few years into this process. And you can't imagine that happening with LLM or physical world model, but this is a reality for drug design models today.
Yeah. Very interesting. Yeah, and really high stake. These discoveries, a lot to expect there.
Yeah.
Great. So we talked a lot. We talked about the foundation models, kind of the difference between the AI ecosystem in US and China. We talk about different applications. So my last question, what would you say is the one biggest misconception that Silicon Valley has about China's AI ecosystem, China's AI development and tech in general?
I won't attempt to say that I understand the whole perception of U.S. U.S. ecosystem of China. But I think there's a lot of, in my opinion, that the U.S. ecosystem think of the China AI ecosystem or the labs or the technology. A lot of this is the result of their improvement is entirely tied to government support, and either from funding or compute or all that stuff. They give a lot of credit to how the government support this. I think they haven't given enough credit to the individuals, to the entrepreneurs, to the researchers that are actually making this happen in a very difficult constraint in the world. I think they were able to be able to do this anywhere in the world if they're able to do this in China today. So that's probably
Yeah, totally. Great. Yeah, I think that's all the time that we have today. Thank you so much for joining us, Xing. Any last words?
No, thank you. Thank you, Greg. Really glad to be here. Thank you.
So this is my conversation with Xing. In the English channel, we're going to publish more video podcasts like this, and we're also going to publish more in-depth explainers about AI technology and everything in between. Hit the subscribe button if you would like to see more content like this. Thank you so much for watching. My name is Yiwen, and this is Valley 101. See you next time.